So in today's lesson, we want to work on division of polynomials. And the first way we're going to show you is by doing something called long division. It should look quite familiar from our days back in elementary school. So we take 3x squared minus 29x plus 56, and we divide it by x minus 7. Now, when we do this, we want to focus on strictly the first term. So we ask ourselves, x times what gives us 3x squared? The answer, of course, is 3x. I'm going to put this in parentheses because it's going to remind us that we have to use the distributive property. We take our quotient, 3x, times our divisor of x minus 7. We get 3x squared minus 21x. And remember, in division we subtract, so I'm going to put a subtraction out here. So 3x squared minus 3x squared cancels. Negative 29 minus minus becomes actually plus, so that leaves us with negative 8x. We bring down the next term of 56. We ask ourselves, x times what is negative 8x, so that's negative 8. Negative 8x, negative times negative becomes a plus 56. And again, we'll subtract these. Negative minus negative, those cross. 56 minus 56, we get a remainder of 0. So thus, the answer, the quotient, is 3x minus 8. Now, we can use division to check for factors. Because remember, if a number is a factor, when we divide it, it must come out to a remainder of 0. So again, let's go ahead and set this up. 3x to the fourth minus 4x cubed plus 12x squared. Notice that there's no linear term here, so I'm going to add in a 0x to account for that linear term. Then our constant term of plus 5. We're going to divide it by x squared plus 1. So again, we worry strictly about the first term of what we're dividing by. So how many times does x squared go into 3x to the fourth? Well, that's 3x squared. And again, we're going to distribute this. So we get 3x to the fourth plus 3x squared. And again, we're subtracting. So notice there's 0x cubed here. So negative 4 minus 0 would be negative 4x cubed. 12x squared minus 3x squared is plus 9x squared. Ask ourselves, x squared times what is negative 4x cubed? Well, that would be negative 4x. So we get negative 4x cubed minus 4x. So again, I'm going to line it up underneath the like terms, which means I need to bring down my 0x. And again, I'm going to subtract these. So let me show the parentheses. Negative 4 minus negative 4, well, that's nothing. 9x squared, there's no x squared to subtract it from. And 0 minus minus becomes plus 4x. What times x squared is 9x squared? That leaves us with plus 9. So again, we get 9x squared plus 9. So that means I'm going to have to bring down my 5. And again, we're going to subtract these, so that's going to cross these out. Let me bring this over here. 4x minus nothing would be 4x, and 5 minus 9 is minus 4. Now, since the degree of the remainder is less than the degree of the divisor, we're done. We can't divide anymore. Is it a factor? No, because we have a remainder. Let's do another example of that. Let me find a little blank space here. So it's x cubed plus 4x squared plus x minus 6. And the question is x plus 2 a factor? So again, we're going to do our long division. Let me get rid of this because I put it right in the way. So we'll go with a blue this time. And again, we're asking ourselves, is x a factor of x? How many times will x go into x cubed? So we start with x squared. And again, we have to distribute it. So x cubed minus x cubed, those cancel out. 4x minus 2x squared is 2x squared. We'll bring down the x this time. X times what is 2x squared? So that's plus 2x. 2x squared plus 4x. And again, we subtract, always subtracting in division. So x minus 4x, that's negative 3x minus 6. So x times what is negative 3x? It's negative 3. And again, we'll have to subtract. Negative 3x minus negative 3x, those cross. Negative 6 minus 6. So is x plus 2 a factor? Yes. X plus 2 is a factor. Because the remainder is 0. Now, the next thing we want to do is show you an easier way that we can do division with. And that process is a process known as synthetic division. Now, synthetic division only works when your divisor is of the form x plus or minus a. It cannot have any degree other than 1, and it cannot have a coefficient in front of your x. So to do synthetic division, the process that we use is we're going to draw an upside down division symbol this time. And inside our division symbol, we're going to put the coefficients of our dividend, what we're dividing in other words. So it's 1x cubed, it's 0x squared, it's negative 57x, and it's plus 56. Now, in division, of course, we always do subtraction, but remember, subtraction is to add the opposite. So we're going to put the opposite of our divisor. So again, these are the coefficients and this is the opposite of our divisor. So minus 7, its opposite being plus 7. Now what we do in synthetic division is we always bring the first coefficient down. And then we multiply. So 7 times 1 is 7. We add the column. 0 plus 7 is 7. We multiply. 7 times 7, that's 49. We add the column. So that's negative 8. 7 times negative 8, that's negative 56. Add those, we get 0. This, the last column, is our remainder. And these are the coefficients of the answer. Now the answer is always going to be one less degree than what we started with. So this is an x cubed. That means our answer is going to be a 1x squared. And then we just go down. Plus 7x minus 8. And since there's a remainder of 0, we don't have to show it. Let's do another one of these synthetic divisions to show you how we're doing. Let's go with x cubed minus 7x squared minus 7x plus 20, and we'll divide it by x plus 4. So again, we're going to write our upside down division symbol. Coefficients are going to go inside. 1, -7, -7, and 20. And the opposite of our divisor is going to go on the outside. So when we start synthetic division, we drop the 1, we multiply, we add the column, we multiply, we add the column, we multiply. You might want a calculator here if you're not too good with your multiplication facts. This one does have a remainder. So then here comes the coefficients of our answer. So our answer is 1x squared minus 11x plus 37, and the remainder is negative 128. Some people will have you write the answer out this way. X squared minus 11x plus 37 minus 128 back over our divisor of x plus 4. And that's how we do synthetic division. Now, one of the reasons why we like to use synthetic division is because of this thing known as the remainder theorem. If you divide a polynomial by x minus a, the remainder is p of a. So, taking a look at our example of x to the fifth minus 3x to the fourth minus 28x cubed plus 5x plus 20. What is negative 4? So, again, we're going to do our synthetic division. So we have our coefficients, 1, negative 3, negative 28. Notice you don't have an x squared, so I put it as 0 for my x squared, 5, and 20. Now, since we're not given a factor, we don't do the opposite this time. We do exactly as it is, and that's 1. Or negative 4, excuse me. When we did the synthetic division back here, we were given a factor, so we do the opposite. But in this, we're given the actual number, so we don't. So again, synthetic division, we drop the 1. Negative 4 times 1, well, that's negative 4. Add the column, negative 7. Multiply, 28. Add the column for 0. Multiply to get the next number, 0. Adding is 0. Still lots of zeros here. 5, negative 20, and the remainder is 4. So this tells us that p, the polynomial function, the quintic polynomial function evaluated for negative 4 is 0. Let's do a second example of that. So we're going to do p of x equals 2x cubed minus x squared plus 10x plus 5. And we'll do a challenge one here. We'll do half. So again, here's our synthetic division bar. I have every coefficient. I have a cube, a squared, a first, and a constant, so no zeros need to be added. So I'll put our half out here that we're dividing by. Again, we'll drop the 2. We'll multiply 1/2 times 2, that's 1. Negative 1 plus 1 is 0. Half times 0 is still 0. 10 plus 0 is 10. Half of 10 is 5. 5 plus 5 is 10. And thus the polynomial function for a value of 1/2 is 10. Now, final thing that we can do is we can use synthetic division to completely factor a polynomial, such as this. Y equals x cubed minus 4x squared minus 9x plus 36, and we're told that x plus 3 is a factor. So what we do is we divide, and again we use our synthetic division. 1, negative 4, negative 9, 36. Again, since it's a factor, I have to do the opposite. So when we do the synthetic division, we drop the 1, of course. Negative 3 times 1 is negative 3. Add that column for negative 7. Negative 3 times negative 7, well, that's positive 21. Add that column for 12. Negative 36. Remainder is 0. So we do see that x plus 3 is in fact a factor because we get 0. Now, we're left with the trinomial x squared minus 7x plus 12. And we get this down to a nice quadratic trinomial that we can factor. We look for the factors whose product is 12, but whose sum is negative 7. That becomes x minus 4, x minus 3. Don't forget the original factor that you have, and you get the complete factorization of the cubic polynomial. And that is how we do division.